All right, ladies and gentlemen, 3.4 today, looking at the properties of logarithms. These are some pretty important properties that we need to learn along the way of our study of logarithms. So let's get going and started. So the properties of logarithms that we have here today, the first one being the product rule. So the product rule is saying if I have the logarithm base b, any base that I want, the logarithm of the product of two things becomes the logarithm of the sum of the two original things. So the log base b of a plus log base b of b. Notice we kept the same base in both the logarithms. We also have the quotient rule. The quotient rule being basically the same thing. This tells me that log base b of a over b is equal to log base b of a minus the log base b of big B. So if we have the log of a quotient, we can create it, or we can say that it's actually the logarithm, actually the difference of the two logarithms. And the last of our three rules here is the power rule. And the power rule states that if I have the logarithm of something to an exponent, I can bring that exponent down to the front of the logarithm and multiply by the log base b of a, whatever the base was in that exponential piece. So one of the big things that we do with this is kind of more of a puzzle thing than it is actually doing any solving. And so we actually just rewrite our functions. So we rewrite this particular function, or expression, I guess. We can rewrite this particular expression as just a bunch of pieces. And so this would be the log of a big product. So I would rewrite this as the log of 8 plus the log of x plus the log of y squared. Now, this technically isn't done just yet because I need to get rid of this exponent in the 2 here because it's just not fully expanded yet. This is actually called expanding our logarithm. Okay, so this actually is going to equal the log of 8 plus the log of x plus 2 times the log of y. So notice the first step that we did up here was just to use the product rule. And then the second step was, we'd already done the product rule, so the last step right in here was to do the power rule. Okay? So that one's done there. That's actually the final answer here. Oops. Next example is the natural log, because it's still a logarithm, so it still follows the same rules. So this is the natural log of the radical x squared plus 5, so that's the numerator, divided by x. X is not under the radical in this particular case. So I get the natural log of a quotient in this case. So I'm going to rewrite this as a difference so I get the natural log of the radical minus the natural log of the denominator. But again, that's not done because the square root is actually an exponent. So I actually want to get rid of that square root as well. So I'm going to move this out and use the power rule. The power rule says this is a half exponent. So I'm going to bring the half in front of the natural log. And it's going to be times x squared, or not times, of x squared plus 5 minus the natural log of x. And that's it. You can't do anything else. Be very, very careful here. Don't be tempted to try to break up this natural log. I know a lot of you guys are going to be super, super like just, I want to do it. I want to do it. But there's no property that we have for logarithms that say you can do that. So we can't do it. So this is your final answer. There's nothing left that you can do. Okay, so those two examples were expanding our logarithm. What I want to do now is I want to combine our logarithm. So notice we have three kind of different pieces going on here, and I want to combine this into a single logarithm. And I'm not going to do anything to the first piece just yet. I have to take care of some other stuff over here on the right. And I'm not even going to deal with the 2. I'm going to deal with the stuff that's inside this parentheses, this big parentheses. This is the natural log of x plus the natural log of y. Well, our property says if I have an addition, I can write it as the product of the two pieces. Now I need to take care of the 2. I'm going to use my power rule. Oops, those are supposed to be 5s, aren't they? Doop-a-doop-doo. Okay, so the 2 for my power rule says this 2 has to go to an exponent on both of those x and the y because it's both part of it, the natural log. So this becomes the ln of x squared and y squared. And now I have a difference of 2 natural logs, so I can bring this right up here and say, okay, the natural log, the difference of 2 natural logs becomes the quotient of the 2 pieces. And then I can technically simplify this. So because I have 2 on the top and 2 on the bottom, oops, that's supposed to be a 3. Oh, it's too ugly. Too ugly for me. Can't leave it. Okay, so right there, and make this a 3 over y squared. And there's your answer. Okay, so using the product rule, the quotient rule, the power rule, we can simplify and expand our logarithms however we need to in the particular problem that's being asked. Now, these were kind of simple ones. We will be asked to do some harder ones later on, either with me or from the textbook, one way or the other. These end up just being kind of puzzles, just kind of like putting it together or breaking them apart, getting them down to the simplest thing that you can have. All right, so the last thing here is what's called the change of base formula. Now, this used to be more important when we couldn't plug different bases into our calculator, but we can actually plug different bases into our calculator now, but I still want to be able to do this by hand. Sometimes this is kind of a handy tool to have in your toolkit. So what this is saying is I can take the log of any base of anything, whatever it might be, and change it to any new base that I want. Log base A, I can change log base B into log base A by basically doing the log base of the thing that was originally on the inside divided by the log base A of the original base. So I'm going to look at this problem here. I'm going to look at log base 2 of 5, and I'm going to rewrite it into a couple different bases. The first one is I want to rewrite it in base 5. Now, this doesn't help us calculator-wise, but it does. It just kind of shows the concept. So log, I want to change it to base 5. So I'm going to say, okay, this is log base 5 over log base 5. And it's whatever was the original piece. So the original piece on the inside was 5. So my numerator is my 5. Get rid of that there. Hey, where'd that go? Okay. Over the log base 5 of the original base, so over 2. And this could actually simplify if you remember our properties from previous lesson. Log base 5 of 5 is 1 over the log base 5 of 2. And to me, that's kind of interesting. It's kind of cool that the log base 2 of 5 is actually the reciprocal of the log base 5 of 2. I don't know why that's cool to me, but it just is. You guys kind of figured out my humor by now, or my things that interest me. Okay, so if I want to change it to base e, this would actually be a calculator one. Base e is our natural log. So I can write this as the natural log of 5 over the natural log of 2. And that's actually it. That's all you can do. And why this is nice is that means you can plug it into your calculator without having to find the change of base logarithm on your calculator. This is much easier to type in and much faster to type in than finding the log base button. Okay, so the last one here. Base 10. This is kind of the one that we like because, I don't know why, most mathematics classes use natural log over the common log just because it's much easier when we get to calculus to use natural log, the base e, rather than it is to use log base 10. But we'll do this as well in log base 10. So I get log of 5 over log of 2. Now, one thing that kind of interests me is to show yourself that these two things are equal. Because this statement, log base 2 of 5, has to be one number. It can't be two different numbers. So you can show yourself on your calculator that those two things are equal. And that's kind of cool. You can change it to any base, and it doesn't matter what number you put down here. Log base 2 of 5 over log base 2 of 2. Log base 7 of 5 over log base 7 of 2. It doesn't matter. You're always going to get the same number. So verify for yourself on your calculator that these two things are equivalent. Hopefully you've done that. You can actually do that on your phone too if you're one of those weirdos that likes your phone calculator. All right. What about changing it to base 1? What about that? Maybe give you a second to think about that. And I hope you're thinking to yourself, Mr. messing with us because we can't do that. By our definition of logarithms from the previous lesson, it says we can't use base 1. Logarithms base 1 don't make sense. They don't exist. So this is a no-no. Don't do it. No can. All right? Hey, guess what? It's done already. That was too quick. Okay, so your lessons right here, you guys have this on your assignment sheet. Remember to get these 8 problems done by the end of class tomorrow, or Wednesday actually. So you guys actually have quite a bit of time before this one's actually due. All right, have fun on your math. See you guys later.